lines that we had in some of the past videos, but now we're going to be focusing on parallel and perpendicular. Previously, we've talked about parallel and perpendicular in terms of just the slopes, but now we're going to be finding the equation of the entire line. So parallel lines are going to have the same slope. If you look at the two lines that are given here, y equals 2x minus 4 and y equals 2x plus 1, both of the equations have a 2 in the m position. Again, we're looking at y equals mx plus b. So this m position, whatever's there, is going to be your slope. They are the same, which means those lines are parallel. For perpendicular lines, your slopes are going to be negative reciprocals. So that means whatever the slope of one line is, you are going to flip it, change the sign, and that's going to be the slope of the other line. So this first line has a slope of 3. Well, if I take 3, remember that's really 3 over 1. So I'm going to flip that and put a negative with it, and that would give us negative 1 over 3, which is the slope of the other line. That means that those two lines are perpendicular. So we're going to still be using point slope form, which I will write in the next example, but now with parallel and perpendicular, you need to think if it's saying that the lines are parallel, your slopes are going to be identical. If it's saying that the lines are perpendicular, you're going to have to change it to negative reciprocal. So this is example 4. Again, this is a continuation of our previous lesson on writing equations of lines. We're going to write the equation in slope-intercept form. So my final answer needs to be in y equals mx plus b form for the line that's going to pass through 3, negative 2, and is perpendicular to the line y equals negative 5x plus 1. The slope of this line that's given is negative 5. The perpendicular slope, and this is the shorthand that I'm going to use for this. I get kind of tired of writing the word perpendicular out. So in math, if we draw an upside down capital T, that actually means perpendicular. Maybe I can write that a little neater so that you guys can actually read it on the screen. There you go. So that upside down T means perpendicular. So if the slope of my line is negative 5, the perpendicular slope, I'm going to flip that, change the sign. The perpendicular slope is going to be a positive 1 over 5. So now I have a slope. I have this thing here, and this is merely a point. It doesn't tell me the y-intercept, so I can't jump straight to this y equals mx plus b equation. I have to do something else first. And that's where the point slope form comes in. Y minus y1 equals m times x minus x1. And again, we're going to be plugging in for the y1, the m, and the x1. So I have y minus my y1. Well, my y1 is going to be the y-coordinate of this point. So that's negative 2. And it's equal to my m, which is my perpendicular slope because I wanted to find the perpendicular line. So that's 1/5 times x minus my x1, which again up from that original point is 3. My final answer is going to have to be in y equals mx plus b, so I'm going to have to rearrange this equation so that the y is by itself. Minus negative 2 is going to become a plus 2. I'm going to distribute the 1/5. So we have 1/5 x minus 3/5. 1/5 times negative 3 is negative 3/5. And then I'm going to subtract the 2. Now this is where I can see some problems happening with this. You won't see too many questions from me where I have you combine fractions together. But just as an aside for you to take a look at that, maybe we can find some colors here. So this negative 3/5 minus 2. I just box this off as a separate thing. In order to subtract fractions, they have to have the same denominator. This 2 is really understood to be over 1. So my common denominator is going to have to be a 5. Between 1 and 5, common denominator is going to be a 5. To turn the 1 into a 5 by multiplying, I would have to multiply the bottom by 5. To keep your fraction equaling the same thing, you have to multiply the top by the same number. So that top, instead of a 2, is going to become a 10, because 10 over 5 is the same thing as 2 over 1. Once your fractions have the same denominator, then you can go ahead and subtract them. The denominator is going to stay a 5 if we don't change that through subtraction. Your top, negative 3 minus 10, is negative 13. So my y-intercept, because that's what you get whenever you combine these two numbers together, is negative 13 over 5. This is a perfect example of why point-slope form is so important. This is not a problem you would be able to graph and figure out the y-intercept because it's a decimal. Negative 13 over 5 is negative 2.6, and you might not be able to see exactly on a graph where negative 2.6 falls. You would know it's in between negative 2 and 3, well, negative 2 and negative 3, but you might not be able to see exactly what it is, and that's why this form is so incredibly useful. So perpendicular, an equation in slope-intercept form, y equals mx plus b, that's perpendicular to this line that's given, is what I boxed in for my answer. Parallel, you would do the same type of process. The only difference is instead of changing the slope to be a negative reciprocal, you would use the identical slope from the equation that was given. I hope this was helpful, and please contact me if you have any questions.